This is lesson 7.4, Parallel Lines and Proportional Parts. Your objectives are to use proportional parts within triangles and to use proportional parts with parallel lines. In any triangle, a line parallel to one side of a triangle separates the other two sides proportionally. This is the triangle proportionality theorem, and the converse is also true. So when that happens, you can make a proportion with the other two side lengths. If that segment in the middle intersects the midpoints of the two sides, then that segment is a midsegment. The triangle midsegment theorem says that a midsegment is parallel to the third side and it's half of its length. So you can make a formula that says the midsegment equals half of the third side. Number 2. On this one, the parallel segment in the middle of the triangle cuts the other two sides proportionally. Set up your proportion with the values sitting the same way that they sit in the picture. 20 goes over x, and that equals 18 over 9. Solve the proportion, cross multiply and solve. And x is 10. Remember, when the segment in the middle is parallel to one of the sides, then the other two sides are cut into proportional parts. Number 4. Here we have a segment in the middle that's parallel to the third side, so it cuts those two sides into proportional parts. This time the triangle is tipped over on the edge, but the proportion can still be set up based on the way that the numbers are sitting in the picture. On the left we have 24 over 30, just like it sits in the picture. On the right we have x over 10, just how it sits in the picture. So you can solve that by cross multiplying, and x is 8. It doesn't matter how the triangle is standing. It can be rotated around any way it needs to be, and you can still set up the proportion based on the way the numbers are sitting in the picture. Number 5. Here we have a segment in the middle of the triangle that's parallel to the third side, so it cuts the other two sides into proportional parts. We know the two side lengths on the left. We don't know both of them on the right, though. We're missing the bottom segment. Well, if the top part is 11 and the whole thing is 33, 33 minus 11 is 22 to get the bottom part. And now you can set up your proportion. Use the numbers just the way they're sitting in the picture. On the left, x over x plus 12 equals, on the right, make sure you do 11 over 22. 33 is the whole thing. We don't need that. Just do 11 over 22. And now cross multiply. Make sure that you put the x plus 12 in parentheses and that you remember to distribute. 11 times x is 11x, and 11 times 12 is 132. Go ahead and finish solving. And once you finish it up, x is 12. Just watch out for those whenever they give you one segment and the whole thing, and you need to do segment addition to find the missing part. When 3 or more parallel lines cut two transversals, they separate the transversals into proportional parts. If the ratio of these parts is 1, then the parallel lines separate the transversals into congruent parts. Number 2. Here you have 3 parallel lines that intersect two transversals, So it cuts those transversals into proportional parts. If you look at the three parts on the left, they're all congruent. And if they're all congruent on the left, then they're all congruent on the right. To solve for x, pick two of them, make them equal each other. Pick the two easiest ones. I think x plus 3 and 12 are the two easiest ones. So x plus 3 equals 12. And x is 9. So when parallel lines intersect transversals, it cuts those transversals into proportional parts. When those parts are congruent on one side, they're congruent on the other side too. Number 4. We have three parallel lines that intersect two transversals. Those are cut into proportional parts. Set up the proportion just the way the values are sitting in the picture. The left fraction will be 5 over 8. And the right fraction is y over y plus 2. Then cross multiply and solve. Remember to put y plus 2 in parentheses and distribute properly. 5 times y and 5 times 2. Then go ahead and finish solving. So y is 10/3. When parallel lines intersect transversals, it cuts the transversals into proportional parts. Number 6. Here you have three parallel lines that intersect transversals. Those transversals are cut into proportional parts. Even though that the parallel lines are going up and down instead of sideways, we can still set up the proportion using the values just the same way they sit in the picture. The left fraction will be 16 over y, and the right fraction will be 32 over y plus 3. There's lots of ways to set up these proportions. No matter which way the picture is sitting, you can set the proportion up using the exact same way the values are sitting. Go ahead and cross multiply. And remember to put the y plus 3 in parentheses so you can distribute. So y equals 3. Just make sure that your proportion is organized. It's set up the exact same way that the values are sitting in the picture. This is lesson 7.5, Parts of Similar Triangles. Your objectives are to recognize and use proportional relationships of corresponding segments of similar triangles and to use the triangle angle bisector theorem. When two triangles are similar, corresponding altitudes, angle bisectors, and medians are proportional to the corresponding sides. Find x. For number 1, we have two triangles with the medians drawn. Remember, the median goes from a vertex to the midpoint of the opposite side. Well, the medians are proportional to the sides. So let's match pieces up. The median on the left is 20, the median on the right is x. The side on the left is 36, and the side on the right is 18. So let's set up our proportions using those values. Median over median equals side over side. Go ahead and cross multiply and solve. So x is 10. The medians are proportional to the sides. So match them up, organize it, set up your proportion, and solve. Number 2. Here you have two similar triangles and the angle bisectors. You know they're angle bisectors because you can see the two angles are cut into two congruent halves. The angle bisector on the left is 9, and the one on the right is 6. The side on the left is 12, and the side on the right is x. Make your proportion and organize it properly. For the angle bisectors, do 9 over 6. For the sides, do 12 over x. And cross multiply. When you solve, x equals 8. The angle bisectors are proportional in similar triangles. Number 3. Here we have two similar triangles and their altitudes drawn. It's the altitudes because it goes from a vertex to the opposite side, hitting the opposite side at a right angle. The altitude on the left is 3, and the altitude on the right is x. Those are proportional the same way the sides are. The side on the left is 4, and the side on the right is 3. So set up your proportion. For the altitudes, 3 over x. For the sides, 4 over 3. We organized it. Left triangle over right triangle equals left triangle over right triangle. Now cross multiply and solve. You get 9/4. The altitudes are proportional to the sides in similar triangles. The triangle angle bisector theorem says that an angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. Find the value of each variable. Number 1. Here you have a triangle with the angle bisector. You can see that angle cut in two. The rule says that the side that intersects is cut into lengths that are proportional to the remaining two sides. The way to pair things up is just the way that things are sitting in the picture. On the left you have a 25 over 20. And on the right you have x over 28. Cross multiply and solve. When you have the angle bisector that cuts the opposite side up like this, just remember it is proportional and you can set it up using the way the values are sitting in the picture. In this one, x is 35. Number 2. Here we have an angle bisector that cuts the opposite side into two parts. Those parts are proportional to the other two sides. Look at the way the numbers are sitting in the picture. Make your proportion using the same positions that those numbers are in already. The left fraction will be 15 over a. The right fraction will be 9 over 3. Cross multiply and solve. For this one, a equals 5. Just remember, when you have the angle bisector, it cuts the opposite side into parts that are proportional to the other two sides of the triangle. That part A will match that side 15, and the part 3 matches that side 9. Number 3. We have an angle bisector that cuts the opposite side in two. Those two parts are proportional to the other two sides of the triangle. Notice though, we don't know the opposite side part that's on the left. The right part's in. The whole thing is 46.8. To get the left side, do segment addition, which would involve taking the whole thing minus the part you know. So that will simply be 46.8 minus n. When you don't know one part, do the whole thing minus the part you know. And now you can set up a proportion. You can use the values just the same way they're sitting in the picture. 46.8 minus n over 36 equals n over 42. We're not going to use 46.8 because it's not a part that we need. We'll only use the other parts. The two sides and the two parts of the third side. So go ahead and cross multiply. Make sure you put 46.8 minus n in parentheses and remember to distribute properly. And once it's all worked out, n is 25.2. The angle bisector cuts the opposite side into two parts that are proportional with the other two sides of the triangle.